and hope they'll help you guys get started if you want to write some mobile apps. And the context here is log. I work for, I never realized that, but I work for Uber for X company. It's not what I was thinking, is not the ideal, but I love the company. We do move, so if you have something that needs to be moved out of your house into your house, you put your address on the phone, and it will send 2 movers and a truck. So very simple idea. And the context that is, we didn't have an Android app. I joined the company like, oh, we need to make that happen. And then React Native was coming out with Android, and we went pretty much from that text, from someone complaining there's no Android, to the thing they started in a month, which for us was amazing. Like, it would never happen if we had to go the other way with Android development in Java, I suspect. And we liked it so much that eventually we replaced our iOS app that was written in Objective-C by the same app in React Native. So now we have one code base for the 2 apps, and now release features for both apps at the same time, which is great. So let's get started. So React Native, first of all, is React. And React is a paradigm programming. You might have heard there is like, you can program with objects, you can program with functions, and you can program in reactive style. It's really good for user interfaces, and that's why Facebook eventually, with the huge interfaces they have, eventually wrote React.js, which is the most famous implementation, and the one I'll be talking about the most. So when I say React, it's a JS library that Facebook wrote. And React is all about components. So React, like I said, it's a framework for interfaces. So you pick any interface, like an iOS app, a web view, a web property, and you see what components are making that interface. And what it means is the components, they know how to represent themselves in that interface, and they know how to handle interactions. Like, what happens when the user clicks that icon, the toolbar component knows that. So this is the log app. This is the main, where you request your movers. This is actually the components behind this screen, the iOS. So we have a toolbar, we have a map, we have a button that shows you the location, and we have a button that just a simple button that confirms goes to the next step. So in many ways, I feel like React is very honest. If you had to learn objects before, they tell you, oh, objects relate to real-world objects. But then in practice, you're writing, and you have, UI view controller and factory proxy things, and it makes it really hard to get up to speed and to understand that. So React is really honest. The components I show you, that's what you're actually going to be reading, and that's what you're going to be writing. So let's start here. So what every component has in common is a render method. So that tells, the component knows how it presents itself in the interface. So this is a very simple component. It doesn't have any data. It just has a hello world. And this would be React for web. So basically your component returns XML. And now React Native, your component is going to look the same. You're still using React to define a component. You still have a render method. But now you're delegating everything to React Native components. So React Native gives you a view component that knows how to map some part of the screen. It gives you a text component, so you can write text. And it has images, sliders, and text. So you get the idea. Your component is basically going to call React Native components to present themselves in the screen. Now, it might be weird for some of you, but that thing that the React Native component returns, that is actually JavaScript. It's something that compiles to JavaScript. So Facebook came out with something called JSX. It's their idea to make the code a little shorter. They compiled that to JavaScript. So don't worry about that too much. You're going to see code that looks like XML. It's actually JS in another syntax. As you're learning, you can just kind of write that and you get a feel of how it works. So just a note on that. But going back to components then, going beyond the hello world, the screen I showed you before, this is actually pretty much the render method of that. So we have one request log component that's pretty much the whole screen you see here. And in the render method, we are putting a view with the container style to fill the whole screen. And then we're asking a map to show up. We're asking for the bottom location to show up and the bottom to show up. So like I said again, very intuitive, I feel, very just honest. Now going a little deeper into React, so the other thing components do, like they don't always just render stuff, like there is, of course, many times they have to deal with data. So we have 2 options in React to handle data. One is props and properties that you expose. So those are immutable for you. So here's the example of a button in the log app. Because one of the things you learn in React Native is a button. React Native doesn't offer you a button, so a button is really an area of the screen that has a touch, that can register touch. So you probably have to write a button component yourself, or you might use an open source one. But anyway, so button is an area that has touchable, you can recognize touches, and then it has a label. So the labeling there is something that the component is going to receive. So in my map, in the screen before, I passed the label set pickup location, so that's what the bottom is going to render. So props are immutable. For the bottom, that's always going to be the same. It won't change. Now, if you do need to change data, that is state. So you can imagine on that screen again with the map is moving, right? The location of the map is moving. So that's when you're changing the data. So that's when you need state instead of properties. And in this case, in React, the way it works is you define what state your component has. So I'm saying I have a map center, which it's passed to me as a prop, and I have a location of the pickup, which right now is null. And then you can see on my map component, I have an on-region change. That's a callback that's going to be called every time the region changes in the map. And when I receive that, I update my own state with the new map center, and then I make an API call to figure out what is the address on that location, and then I set that as the new pickup location. So now the bottom is going to render the new location of the map. So props and state, that's the basic, that's pretty much the foundation of React. The one thing I'll mention next for React Native, at least, is that if you're wondering, okay, so we have components, we know how to write, tags and views. At some point, you're going to have to style them, and that's I think what is really interesting. They pretty much implemented CSS3 in JS, so you have stuff like background color and padding and margin, and even flexbox stuff. So you can have views that are aligned in a certain way and centered and centered to the left and to the right. So it feels really familiar for if you know web development already. And I feel like it's much easier to get up to speed than it is otherwise if you're going the iOS way, which is doing view controllers and aligning your code, your views with code. And now, okay, so if this is React Native. I just want to stop like for 2 minutes, just explain a little of what is happening behind the scenes. I feel like it's really valuable to understand a little of, you're like, okay, I'm writing JS, it is native, it's running on my device, but like what is really going on there? So like I said, part of the magic is JSX. So React Native is going to use Babel to compile that to a simpler JS that the JS machine running your phone can read. And it's going to do the same for ES6. So you can use arrow functions and classes. Babel's going to take care of that and compile into simpler JavaScript. And then React Native is going to either serve that or package that with your app. So if you're developing locally, you have a simulator going on. The simulator is going to make a network request to fetch the bundle on demand. So that's why it's really fast to develop on React Native. You can pretty much just reload your iPhone simulator, and it's going to get your latest views. But now, of course, when your app is in the store, you might want your app to work without a network at all. So the bundle, in this case, your JS is going to be bundled with your app, so your app can just read from the desk. So with the bundle, how the app actually works? Well, the React Native apps has actually a foundation written in the native object. So Objective-C, you have a main activity, the app delegate. In Java, you have a Java class, the main activity that knows how to set up the Android environment. So after that is up, it's going to load your bundle, so either from the network or from the desk. And then it's going to start executing your JavaScript in a thread, in the JS thread. And now here comes what I think is the pinnacle, the most amazing thing about React Native, and what really allows this technology to happen. So here you can imagine my JS code, my view. I just rendering as a red square on the screen. That view, I'm rendering the view component. That view is defined by React Native. So you can go to the React Native repo, or you can open Node modules, and you can see what's behind the view. So this is implemented by React Native. You don't have to touch it. I just show you in the code. So in the render of the view, it actually delegates that RCT view. And this is where there is a bridge between JS and native objects. That's where it comes from. So RCT view is a class in Objective-C that extends the UI view. So if you know iOS development, like you have UI views, that's how you create a view in iOS land. The bridge makes that available to your JS classes and objects, which I think is amazing. And more than that, it can transform how the data goes in and out. So that background color red, that object I have in JS, is going to turn that into an NS dictionary. That is the corresponding object in Objective-C. The string, the JS string, is going to be converted into an NS string in Objective-C again. And even the red is going to become a UI caller. So it's going to look up in a table, find the red UI caller, and that's the stuff that you can use with UI view in native land. So React Native, so that's why it's native. You're actually creating UI views in native iOS classes. Only you're triggering that whole tree from JS. At some point after your views are styled, you're going to have to worry about navigation. This is a subject for the whole talk, but TLDR, look at React Native routed flux. So after you have several components, if you want to change how one comes to this thing and out, this is the latest development in React Native. This is what Facebook is behind. Basically, you have a component, and you associate your components with a string. And then, so let's say I have a login component with the key login, so I can call actions.login, and then that React Native router flux is going to bring the new component into the screen for me. And then you have options to bring components modularly and a lot of stuff like that. One other aspect that I think is really cool, you have ways to do platform selection. So in our app, for instance, the search screen is very different from iOS and Android. So we have two components entirely different that do that. They use the same primitives, so same buttons and stuff, but they're very different. So to do that, you can just name the file differently, and then React Native is going to give you the right one in runtime. Or if you want, you can also do platform selection more like inline and on demand. It's a big one in here, but you can see if platform is iOS, do something. If not, do something else. Super cool. When it's time to get to the store, this is probably not what you want to hear here, but it's kind of outside the scope of React Native. So it goes as far as giving you a package app that is ready to go. It's signed, it's an APK for Android, IPA for iOS. You're going to follow guides to throw that in the store. It's a pain in the ass, but there are a lot of resources online. And I'll leave you my email later if you want to talk about that. I can talk about that too. Just two more things quickly. Error tracking is a little different with React Native. You suddenly have Java exceptions coming up and you have JS exceptions. So you might want to use two services to track those, which is what we do. So we have Specialists for the native stuff, and then we use Robot, which is classic JS error service to track errors. React Native gives you a hook you can register yourself to get all the JS errors there. And finally, updates, you have to be aware, React Native is moving fast. It's incredible, actually. There's a release every 2 weeks, pretty much. And every time this happens, some part of the code that you have might not work anymore, and then there's new stuff, which is great. Glad and great. So I recommend you read the release notes. They're great, and they explain you what's going on. And Brent, one of the core members of React Native, he has a newsletter. So he kind of curates what's going on with content. It's amazing. I wish every project I cared had that. So I definitely recommend you follow that up. Oof. So that's it. A bunch of links. If you're interested, I definitely recommend checking those out. Thank you so much. And I'll be around.
That was Pedro. Wow, that was a lot of stuff really quickly. I didn't even know how to react. Trying to